Dear colleagues, dear friends and supporters of ecological restoration, we would like to share with you our experience of integration of peatland restoration project into climate-related reporting in Russia. This study was carried out within the several projects which are listed here, and I will them also mention in the course of my presentation, and with contribution of several co-authors. Vladimir Korotkov and Alexander Trunov from Institute of Global Climate and Ecology, Russian Academy of Science, Andrei Sirin from the Center for the Conservation and Restoration of Wetland Ecosystems of Russian Academy of Science, and Helena Lapshina and Yegor Dyukarev from Yugra State University. We all know that last years countries started to report on the climate-related issues within the national determined contributions, which is the format how Paris Agreement reporting is organized. Nationally determined contributions as a document has several components. The obligations on adaptation and mitigation with the relevant indicators. Besides this, countries have to explain how they will report on these measures in line with the monitoring, reporting, verification principles (MRV), and they have to explain how they will fund these projects and how they will carry out the management. So you see there is 5 components of NDC on this picture. Recently, last year, Wetlands International, together with Alliance for Global Water Adaptation and with the support of GIZ, published a small review which clearly demonstrated the potential role of wetlands and specifically peatlands in the reporting and capacity of these actions to reduce emissions due to land use changes and to enhance adaptation capacity of socio-ecological systems. Here you can see the small infographic sketch how you can assess the changes in the emissions due to different land uses on peatlands, and how you can consider this at the scale of the entire landscape. How we can realize this concept on the project level? We usually consider peatland as an integral ecosystem containing from 3 main components: peat, plants, and water. And we explain this in such a sort of triangular which is presented here. The surplus of water brings specific plants which can form the peat. The forming of peat causes more surplus of water, as peat is attracting water. There are more water, more plants, more peat. Such sort of very resilient perpetuum mobile. We use the concept of the 3 components to set up our reporting. We have consider the ecosystem in the ecosystem the carbon-related features, the biological productivity features, and hydrology, and for Arctic the permafrost-related features. When you have natural ecosystems, we consider that it is the baseline for the characteristic. In the course of land use, these characteristics are changing. We are losing some biophysical features and connected functions. One can try to minimize or mitigate this impact and report already at this stage against the business as usual. And after land use, we apply restoration measures, and we could easily assess what are the gains in sense of the turning carbon source to carbon sink, and in course of the maintenance of other ecosystem services for the case for this project, for this ecosystem. Let's go to the several examples. Here we have the Arctic example. In the Arctic, peatlands are playing crucial role in the protecting permafrost from thawing. The thawing and permafrost is causing huge emissions of greenhouse gases, which are considerably larger than in the other types of ecosystems without permafrost. So natural or moderately used ecosystems are protecting permafrost from thawing and are serving as a sink of greenhouse gases, as well as providing number of significant ecosystem services for local communities. The transformed ecosystems totally lose these features and are very dangerous, especially from the point of view of the greenhouse gas emissions, and rehabilitation measures can bring back more easy vegetation, so biota component, um, less easy water component, hydrology, and it's very difficult to bring back the carbon related features and functions. The same we can apply for the other uses. You can consider what are the impacts of different practices, how they are affect ecosystem functions, what losses of ecosystem functions, and try to calculate this at the same principle. The same example, this is peat extraction example. Peat extraction sure brings more losses than agriculture because we are losing peat. It's very difficult to restore peat. However, we implemented a huge project which is still running in Russian Federation. This is Russian-German bilateral cooperation, technical capacity for the peatlands restoration. It was implemented in a huge area, and there's a lot of many results, and due to this we were able to include these results, the outcomes of this project, to the national reporting. When it comes about the mitigation, we have to apply the IPCC guidelines for the national green gas inventories, the Wetlands Supplement 2013, which provides the clear emission factors and the guidelines how to calculate the outcomes of this project in sense of the reduction of greenhouse gas emissions and turning sources to the sinks. The monitoring is based on the remote sensing, on the assessment and changes of the land classes which are sources to the land classes which are sinks. Sure, we are also doing the on-ground verification of our monitoring. This is the example of the ground truthing and the monitoring work on one of the huge peatlands in the central Russia in Tver region. The same principles could be distributed for the large landscapes, for the administrative units, or even the whole country when you plot the land uses against of the uh, polygons of peatlands, and when you know at which type of peatlands you have which impact of which land use could be interpreted in sense of the emission factors or in sense of the losing of the ecosystem services, which you can possibly assess, and we were trying to do this. Here is the example of the application of the ecosystem services assessment changes due to restoration practices. We took the principles of Society of Ecological Restoration project assessment procedure when they are used the different community or ecosystem features and traits. We replaced these direct measurements of the biophysical traits to the ecosystem services, which had been assessed and evaluated through the stakeholder analysis. And we were trying to use this measure as the indicator of the success of restoration. And if we want to evaluate the benefits of ecosystem services, we can easily apply the standard cascade approach. And we can do this based on the project and on the landscape level. So at the end, this ecosystem services assessment serves as indicator for the adaptation capacity. And so we can have report to our NDC against our NDC indicators, both in mitigation and adaptation. For sure, there are some difficulties on this way, some barriers, but there's also a lot of opportunities, and we call to everybody to introduce their ecosystem restoration projects in the climate-related reporting, and then we together can overcome these barriers. And thank you very much for your attention.